Okay, Assalamualaikum class and very good afternoon. So this will be our first video lecture for ENT493 uh, Advanced Control System. Uh, so this is one of the elective courses, and this video is the introduction video for ENT493. Okay, as introduction about me, as you can see in the slide, my name is Dr. Siti Marhain Usman. I'm a UPN graduate from bachelor degree, master and also PhD, ATM, Johor. So I can be contacted via the email listed or through my phone number. So I believe everyone here has my phone number, isn't it? So my room is in lecture room 26, or most of the time I will be at diploma program share room near FTKE 1 for you. Okay, so you can come here if you will be at hostel or unit if you have any discussion, something to discuss. So this is the location of my room. Okay, now the course details. Okay, the objective of this course is to expose the student with more advanced controls design or control system. But in our courses, it will be limited to adaptive controls, optimal controls, and robust controls. So we will have 5 chapters in this course, and the 3 first chapter will cover adaptive control system. Another 2 is optimal control and robust controls. Okay, lecture hours will be on Wednesday from 5 p.m. to 7 p.m. It's stated as synchronous classes. I will give a video, or I will conduct a Google Meet sessions or WebEx session. I will make announcements before we start the class. And another class is on Friday, 9 p.m. to 10 p.m. Synchronous classes. So I will do a video. And notes, the teaching materials, tutorials, assignment quizzes, I will upload in Classroom, Google Classroom. Okay. So please make sure you are in the right Google Classroom. Okay. I think I already shared the link, and most of you already joined the Google Classroom. Okay. Lecture implementations. So we have 2 class, Wednesday and Friday. So Wednesday, I will give you a video and we will discuss through WhatsApp, or I will conduct a Google Meet or WebEx sessions, and or I will give a video on tutorials, solutions, discussions, explanations, and we will have a discussions through our synchronized classes. Okay, so that's the suggestions of the lecture implementation during Wednesday. While for Friday classes, uh, most of the time I will give you a video. That's a 9 p.m. class. Okay? I think most of you already sleep, right? Or playing a game and so on. So I will give you a video. You will go through the video and we will discuss. We will have a discussion, a serious discussion, of course, on Wednesday class next week. Okay, so I think that's the lecture implementations for this course. Okay, course contents over 14 weeks. So we have 5 chapters. Okay, adaptive systems, self-tuning control (STC), and model reference adaptive control (MRAC). So these 3 chapters cover adaptive systems scope. While chapter 4 is about optimal controls, while chapter 5 covered robust control system. So this the this distributions of the course content uh, through weeks, 15, 14 weeks, 14 weeks. So about 3 weeks per chapter, and we will have a midterm date on week 8. Okay. I haven't get a new info about the academic calendar and so on. So I think this is just a brief, um, it's a planning of the course. Maybe there are a few changes on weeks or allocations or midterm break or so on. But we stayed with the week distribution for the chapter. Okay, so the control will be take around 3 weeks to complete, self-tuning control STC about 2 weeks, MRAC about 2 weeks, and optimal controls 3, and robust control about 2 weeks. Okay, so I think this is a very fun, it's very fun course. I think you will miss me a lot at the end of this course. Okay. Okay, course outcome for ENT493. There are three course outcome for 493. Course outcome number 1, ability to analyze the concept of adaptive, optimals, and robust control. Course outcome number 2, ability to design something using adaptive, robust, or optimal control. And the last course outcome, course outcome number 3 is ability to evaluate the suitability of the controller. Which one you want to use based on the behavior of the case study that will be given. So this is the course outcome for our subject. Okay. Okay, so this the level of complexity based on the Bloom taxonomy. So in our course, the level of complexity will be up to C6. So you have to create something. Okay, the lowest level of complexity is C4. So you must be able to analyze, you must be able to evaluate, and you must be able to create something in this course. Okay. Okay, so this is something that you have been waiting for, I think. The assessment component. Initially, we will have a final exam up to 60%, one quiz, one test, a few quizzes and assignments, and so a design project, something. But because these are our new norms, and most probably you will have final exam will be not conducted. Okay, so this the planning of our course assessment. Okay, it's not been finalized yet, but I think overall it will be like this. So quizzes will be 10%. Number of quiz is not being revealed. Okay, assignment is 10%. I think maybe around 2 assignments will be given. Case study and problem solving. Um, this will be a group assignment, about 2 or 3 students per group, but it will be an individual report. Okay, around 10%. And test 1, more on theoretical concept, fundamentals, maybe ability to analyze something, about 30%. Okay, and the last one is test 2, open book test. So you have to design something. Since it's an open book test, so the question is quite okay. I believe you can answer it, but you have to refer something here and there. So around 40%. So the total is 111. Okay, 100%. That's nice. Okay, reference books for this course. So this is the reference book for the control. So either one, you can Google and get the PDF. Books also available. So for Astrom and Well State, that one is Goodwin. So these are very good books for adaptive controls. I will update about the reference books for optimal and robust controls before we start chapter 4 and 5. Okay. Okay, now an overview of the first chapter, adaptive controls, self-tuning controls, and modern reference adaptive controls, or we can call it as MRAC. Okay, you will get familiar with the terms after this. Okay, now adaptive control. Okay, apa tu adaptive control? What is the definition of adaptive control? What adaptive is all about? Okay, in everyday language, okay, cakap to adapt means to change a behavior in order to conform a new circumstance. So, that's in English terms. Okay, so to adapt means to change a behavior. To adapt is to change a behavior. So adaptive controller is a type of a controller that can modify its behavior. Okay, so to adapt is to change a behavior, and adaptive controller is a controller that has an ability to modify its behavior in response to the change in the dynamic of the process or the character of the disturbance. Okay, it's sudden disturbance, or maybe a fixed disturbance, or adjustable disturbance, and so on. But the most important thing is the controller itself. It has an ability. You change, I will change my behavior. The system changes on something, I will modify my behavior. So that's the ability of the adaptive controls. So as you can see in the slide, okay, this is the figure of block diagram of adaptive control. Kita pakai pointer sikit. Okay, so this is the block diagram of an adaptive control system. Okay, so we have a controller. Initially, a control system, as you have learned during control engineering 1 and control engineering 2, so this is the block diagram without the parameter adjustment. So the block diagram for control systems is a controller, client, okay, control signal U, okay, output and input or setup, and we have a feedback loop to the controller. Okay, so that's initially the block diagram of the control system. However, in advanced and adaptive systems, there are one block which is parameter adjustment, and the input for this block is the output of the controller, and we call as the controller parameter. And the second input for the parameter adjustment block is the output of the line. Okay, so that's the block, the new block added for adaptive controls, how we change from a control system, original control system, to the advanced adaptive control system. Okay, so and the parameter adjustment loops. Okay, we have one loop, the parameter adjustment loop is often slower than the normal feedback loop. So this loop is often slower. This loop is called as the parameter adjustment loop. Is much more slower than the normal feedback loop here. Okay, so overall, this is the adaptive control system block diagram. Initially, in control system, we have controller, we have line, output, and input here, and so we have a feedback loop. However, in adaptive controls, we have a parameter adjustment block, and we also have a parameter adjustment block, where the input for this block is output from the plant and the output from the controller itself. Okay, and also the setup that we have set initially. Okay, now you know that adaptive controls is the systems or controller that have an ability to modify behavior. So there are two types of adaptive control. Actually, there are a lot of types of adaptive controls, but for our course, we just cover two types, which are self-tuning control or STC, and model reference adaptive controls MRAC. Okay, so what is self-tuning control, and what is the definition and more model reference adaptive controls? Okay, development of a control system involves many tasks such as modeling, design of a control law, implementations, and validation. So the self-tuning control attempts to automate several of these tasks, and the term self-tuning was used to express the properties that the controller parameter converge to the controller that was designed if the process was known. Okay, while for model reference adaptive control MRAC was originally proposed to solve a problem in which the performance specifications are given in terms of a model reference. So here, the model reference. This model tells how the process output ideally should respond to the common signal. So here is the common signal. Okay, so the response, the process output is Ym. Okay, a block diagram of the system is shown in figure 1.18. So the controller can be thought of as consisting of two loops. The inner loop is an ordinary feedback loop, consists of the process and the controller. So this is the inner loop. While the outer loop adjusts the controller parameter in such a way that the error, which is the difference between process output Y and the model output Ym, is small. So here is the error. Difference between Y and Ym is small. So the key problem of the MRAC is to determine the adjustment mechanism so that a stable system which brings the error to 0 or nearly 0 is obtained. So this MRAC is all about. Okay, to see in a bigger picture what adaptive control is all about and what is its ability compared to another controller. So this figure shows the comparisons of the adaptive controls and the conventional controllers such as PI, PID, PD, and so etc. So in this figure, there are a change of the plant model parameter occur at the t equal to 150. So there are plant model parameter change. Okay, the adaptive controller model pun yes, dekat conventional controller model pun ada occur. So you also know, I also know, everybody know that conventional controller has a constant parameter. So once there are parameter change, sudden parameter change occur, so we can see a poor performer result start to occur. So the model is not using original parameter when you tune the conventional controller. So they suddenly occur at t equal to 150, so it cannot compensate the disturbance or the parameter change. Compared to the adaptive controller, we have tuned the adaptive controller. We get the parameter that suit the uh, plant model parameter and the adaptive control parameter at that time. But suddenly there are plant model parameter change. It does give transient. We call it as a adaptation transients at the beginning at t equal to 150, but after the adaptation transients, the performance is better. We're able to give a good performance compared to the conventional controller. So that's the ability of the adaptive controller. Okay, I think that's the end of our first video lecture. So I have briefly explained about the planning of this course, assessments, apa lagi dari cerita, and overview of the three first chapter that covered the adaptive control scopes, such as self-tuning, control, and model reference adaptive controls. So we will go more deeper during this chapter, and I think overall you get an idea what is adaptive all about. So next video lecture, I will go more deeper on adaptive controls, the mathematical equations, the control law that relates to the adaptive controls, how you want to design the adaptive controller, how it change depends the behavior of the case study of the system. So we will go more deeper on that on our next video lecture. So I think that's all for this week. Um, Please take care of yourself. Stay safe. Hope I can see you again. So until next video lecture, take care.